Just quickly hear me out for the next few minutes. This will immensely help you in solving the most important problem from eigenvalues and eigenvectors. So we have to show that the given matrix is diagonalizable, and also we have to find the diagonalizing matrix P. So in this, what is the matrix given? So here the matrix is given as -9 4 4, and this is -8 3 4, and this is -16 8 7. The characteristic equation of A is nothing but modulus of A minus lambda I is equal to 0. So this will be A minus lambda I modulus value is nothing but determinant of 9 minus lambda, this is 4, 4, this is -8, this is 3 minus lambda, again 4, this is -16, 8, and this is 7 minus lambda. First of all, we have to find the determinant for that. So for this, this will be -9 minus lambda into. So if I multiply, so this will be, see, I have to close this row and this column. So this will be 3 minus lambda into 7 minus lambda. 7 minus lambda minus 32. And if you see, the second one is -4 times of. So this is -4 times of. If I multiply, this will be -8 into 7 minus lambda, and this is minus of minus plus 64. And the next element here is 4 plus 4 times of. So this will be, see, if I multiply, this is -64 minus of minus plus 16 times of. This is 3 minus lambda is equal to 0. So if I multiply, then see what happens here. -9 minus lambda is equal to, if I multiply, this is 21 minus 3 lambda, this is -7 lambda plus lambda square minus 32, and this is -4 times of, this is -56, and this is plus 8 lambda plus 64 plus this is 4 times of -64. If I multiply, so this will be 48 minus, so this is again 16 lambda is equal to 0. So this is nothing but -9 minus lambda. So this is lambda square, and this will be -10 lambda. So this is -32 plus 21. So this is -11 minus 4 times of, this is 8 lambda, and 64 minus 56. So this will be 4. So this is 8 plus 8, and this is 4 times of, if you see, so this is -16, this is -16 lambda, and -64 plus 48, this is -16 is equal to 0. So if I still multiply here with -9, so -9 times of lambda square minus 10 lambda minus 11, and minus lambda times of lambda square minus 10 lambda minus 11. This is 4 times of 8 lambda plus 8, and if you see this one, so this is 4 times of -16 lambda. So this is -16 is equal to 0. So if I multiply, so this will be -9 lambda square, this is plus 90 lambda plus 99. If I multiply, this is minus lambda cube plus 10 lambda square plus 11 lambda. If I multiply, this is 32 lambda minus 32, and this is a 64 lambda minus this is a 64 is equal to 0. If you observe this one, so this is minus lambda cube. So this is minus lambda cube, and if you observe this one, lambda square -9 plus 10, so this will be plus lambda square. So this is plus lambda square, and if you see, so this is plus 90 plus 11 plus 32 plus this is minus 64. So this will be plus 5 lambda, and again if you observe, this is 99. So this is plus 99 plus 32, and this is 99 plus 32, and still what else is there here? Plus 32 and minus 64, and this is 96, 99. So this is plus 3. So this is plus 3. So if I multiply with minus, so this will be lambda cube minus lambda square, and this is minus 5 lambda minus 3 is equal to 0. So I have to find the roots for it. In order to find the roots, so this will be the quotient of lambda cube is 1, this is minus 1, minus 5, and this is minus 3. If I try with minus 1, so this will be, if I keep 0 here, this is 1, so this is minus 1, this is minus 2. If I multiply, so this is minus 3, minus 1 into minus 3 is plus 3, and therefore the value here is 0. And what remains here, so this will be lambda square minus 2 lambda minus 3, and here there is already minus 1 as a root, so this will be lambda plus 1. So this will be lambda plus 1 times of, so this will be lambda square 3, so this can be written as minus 3 lambda plus lambda minus 3 is equal to 0. So lambda plus 1 times of, if I take lambda common, this will be lambda minus 3. If I take 1 common, this will be lambda minus 3 is equal to 0. So if I take lambda minus 3 common from this, this will be lambda plus 1, and lambda minus 3 if I take common, this will be lambda plus 1 is equal to 0. So here the lambda values are minus 1 comma minus 1 comma plus 3. So we got the lambda values as minus 1, minus 1 and plus 3. So these are the eigenvalues. Next I am going to calculate the eigenvectors related to this. So in order to find the eigenvectors corresponding to the lambda is equal to minus 1 will be, so in place of this determinant we have to keep lambda is equal to, so we have to keep lambda is equal to minus 1. So this will be minus 9 minus of minus plus 1, this is 4, this is 4, this is 8, and this is 3 minus 1, so minus of minus plus 1, and this is minus 16, this is 8, and 7 plus 1, and this determinant will be, see, so this is minus 8, so this is minus 8, 4, 4, and this is going to become minus 8, and this is 4 and 4, and this is minus 16, 8, 8. So with this, so first I am going to use this first diagonal element and make these two 0. So for that my operations will be, see, in order to make this 0, so I have to subtract this one, so R2 will be as it is minus R1. So using this one I have to make R3 0, so R3 will be as it is 16. So in order to get 16 here I have to multiply and subtract, that is 2 R1. So these are the things which I am going to do now. So R1 is undisturbed, so this will be minus 8, 4 and 4, and see here, so operation here is, so R2, how it's going to change, that is R2 minus R1. So what is R2 here? Minus 8, 4, 4. So this is minus 8, this is 4, 4, and this is minus again. What is R1 here? Minus 8. So minus 8 becomes plus 8, and this is 4 and 4. So total R2 will be 0, 0, 0. And how about this R3? So R3 row will be, the operation here is R3 minus 2 R1. What is R3 here? Minus 16, 8, 8. Minus 16, 8, 8. This is all the rough work. And minus, so I am keeping minus 2 into R1. So we have to multiply with 2. So if I multiply, this will be minus 16. So if I multiply with 2, this is 8 and this is 8, and this value is 0, 0, 0. See here, if you observe, the rank here is 1, and number of unknowns. So unknowns will be, it's a 3 by 3 matrix, x1, x2 and x3. So this is going to become 3. Therefore, the number of independent solutions, the number of independent solutions is equal to, this is n minus r, that is 3 minus 1, 2 independent solutions we can take. So now this can be written as minus 8, 4, 4, 0, 0, 0, 0, 0, 0 into, see here, x1, x2 and x3 is equal to 0, 0, 0. Now this is minus 8x1 plus 4x2 plus 4x3 is equal to 0. So two solutions we can take by our own, that is x2 is equal to, this is k2 and x3 is equal to k1. So two solutions we can choose. So if I substitute the same thing, that is 8x1 plus 4k2 plus 4k1 is equal to 0. So this will be 8x1 is equal to, this is 4k2 plus 4k1, So x1 will be, this is 4 by 8 k2, and this is 4 by 8 k1. So if I cancel this one, if I cancel, so x1 will be k2 by 2, and this is k2 by 2. Therefore our values, that is x1, x2, x3 values will be, see here, what is k1? So this will be k1 by 2 plus k2 by 2. And what is x2? So x2 value is k2. So this is k2, and x3 value is k1. So I am keeping here k1. So if I take k1 common from the first one, so this will be half. So k1, there is no k1 here, 0, and this is 1 plus. So if I take k2 common, then see k2. So this will be half. K2 is 1 and this is 0. So if I multiply with 2, so 2 by 2, this is 1, 0, 2. This is k1 by, again a constant. So if I multiply with 2, so this will be 2 by 2, this is 1, 2, 0. This will be k2 by 2. Therefore our eigenvectors will be 1, 0, 2, and this one is 1, 2, 0. So with respect to lambda is equal to, see here, this is minus 1. So these are the characteristic vectors with respect to lambda is equal to 1. So again, if you see, the next eigenvalue is lambda is equal to, for minus 1 I got, see here I am writing the model matrix P. So what are these? 1, 0, 2 and 1, 2, 0. So this is 1, 0, 2 and this is 1, 2, 0. And next, with respect to 3, we have to find out the vector, that is characteristic root, that is the eigenvector for the corresponding eigenvalue lambda is equal to 3. So for that we have to substitute here in this. So if you, so this will be, C, this will be minus lambda minus 3, this is 4, this is 4, this is minus 8, this is 3 minus 3, this is 4, and this is minus 16, this is 8, and 7 minus 3. So this value will become, this value will be, this is minus 9 minus 3, so which is equal to, this is minus 12, this is 4, 4, this is minus 8, 0, 4, and this is minus 16, this is 8, and this is 4. So first of all, see, there is a, so this is R2, so this is R1, so R1 divided by, so if I divide with minus 4, so this is minus 4, and R2, so R2 if I divide with, this is minus 4 again, and again R3 divided by, again this is minus 4, yes. So if I take minus 4, then see this will be 3 minus 1 and divided by minus 4. So this will be 2, 0, minus 1, and this is 4, this is minus 2, and this is minus 1. Now using this one, using the first diagonal element, I have to make these two 0. So this will be very simple. R2 affected as, in order to make this 0, I have to multiply with 3. So this is 3R1. Again I have to multiply with 2 minus. So this is 3R2 and this is 2R1. And the next one here is R3 affected as. So R3. So again I have to multiply with 3. So this is 3R3 minus, and again this is 4R1. This will be 4R1. See, our matrix will be R2. So what is our R2 operation? R2 operation is nothing but 3R2 minus 2R1. So 3R2. So each and every element we have to multiply with 3. So this will be 6, 0, minus 3 and minus, and we have to multiply with 2. So this will be 6. So this is already minus. This is a 6. And this will be minus 2, and this is again minus 2, it will become plus 2. The first row is as it is, 3 minus 1 minus 1, and the second row is 0, this is 2, and this is minus 1. And how about this third row? So the operation here is 3R3. This is 3R3 minus 4R1. If you observe this one, R3 we have to multiply with 3. So 4 3s, this is 12. This is 3 minus 6, and this is minus 3 minus, and 4 we have to multiply. So this will be 12. So this will be plus 4 and this is again plus 4 and this value is 0 and this is minus 2 and this is plus 1. So again we have to use the second diagonal element. This is second diagonal element and make this 0. So R3 affected as this is R3 plus R2. Then see, this value will be, this is 3 minus 1, 0, 2 minus 1, this is 0, 0, 0. So here if you observe, the rank here is, the rank of A is equal to, the rank of A is equal to 2. The number of unknowns, the number of unknowns is equal to 3. The number of independent solutions, the number of independent solutions is equal to, this is n minus r, this is 3 minus 2, 1. So one independent solution we can choose. So this is 3 minus 1, 0, 2 minus 1, 0, 0, 0 into this is x1, x2 and x3 is equal to 0, 0, 0. And if I multiply, this is 3x1 minus x2 minus x3 is equal to 0, 0 into x1 plus 2x2 minus x3 is equal to 0. So one independent solution I can take, therefore x3 is equal to k. So this is 2x2. So 2x2 is equal to x3, so which is nothing but k, and x2 value is equal to, see, this will be k by 2. So x2 value is k by 2. So if I substitute the same thing here, that is 3x1 minus x2 minus x3 is equal to 0. That is 3x1. What is x2? This is k by 2, and x3, this is k. And see, this is 3x1. This will be 3k by 2 is equal to 0. So x1 will be k by 2. So after getting all the x1, x2, x3 values, see here x1, x2, x3 values. So what is x1? So this is k by 2. What is x2? This is k by 2. x3 is equal to k. So if I multiply with the, if I take k by 2 as common, so this will be 1, 1, 2 into, so this is k by 2. So this is k by 2. So this is the eigenvector related to the eigenvalue. So this is lambda is equal to 3. So for lambda is equal to 3, this is 1, 1, 2. So now I am going to write here. So the characteristic vector, that is 1, 1, 2 with respect to the eigenvalue lambda is equal to 3. Now, so this will be the model matrix. So this is the model matrix. So after getting the model matrix, in order to diagonalize it, so we have to find the P inverse. So it's very simple to find the P inverse here. See here, first of all I have to find out the det, that is 1 into AD minus PC, that is 4 minus 0 minus 1 times of, this is 0, this is minus 2 plus 1 times of, this is 0 minus 4. And det P will be, this is 4 minus of minus plus 2 and this is again 4. If you see, the det value is equal to 2. So here I got the det value is equal to 0. What is P here? P is nothing but 1, 1, 1, 0, 2, 1 and this is 2, 0, 2. So first of all I have to find out the values. So for that, see, all the values here I am going to show. First of all I have to find the cofactor matrix. So this is the cofactor of P. So for the cofactor of P, this is plus, minus, plus, and this is minus, plus, minus, plus, minus, plus. So I have arranged each and everything. For the first element, we have to close this row as well as this column. Then see this matrix, this is 4 minus 0. So this will be plus 4. And if you observe, the second one is like this. So if I close this row and column, so this will be 0 minus 2. Here already there is minus, I am writing plus. And for this element, the cofactor is 0 and minus 4. So this will be minus 4. And for this position, so see here, so we have to close this row and column. So this will be 2 minus 2, this is 0. So if you see the for cofactor, the cofactor matrix will be in this position. If you see, so we have to close this row and this column. So this will be 2 minus 1. So this will be 2. And for this in middle term, so this will be 2 minus 2, so which is equal to 0. And for this position, so this I have to close this row as well as this column, then this will be, see this will be 0 minus 2, and this is going to become minus 2, and this is minus of minus plus 2. And for this position we have to close this row as well as this column. So if I close this row and column, see this will be 1 minus 2, this is minus 1, so this is minus 1. And again for this position we have to close this row as well as this column, and this will be 1 minus 0, which is equal to 1. And for this position, this is 2 minus 0, so this will be 2. And after getting the cofactor matrix, we have to find the adjoint of P. So adjoint of P will be the transpose of this. This is 4 minus 2 minus 1. This is 2 0 minus 1. This is minus 4 2 2. So 2 2. So P inverse value will be, see here, P inverse is equal to adjoint of P by determinant of P. So the P inverse will be 1 by 2 times of, this is 4 minus 2 minus 1, 2 0 minus 1, this is minus 4 2 2. So after getting this, so first of all, what is the P value here? P value is given, so for the to diagonalize the element, so D is equal to P inverse A into P. So P inverse is equal to, what is P inverse? So P inverse is nothing but half times of, this is half times of 4 minus 2 minus 1, this is 2 0 minus 1, and this is minus 4 2 2. And A is nothing but our question. So what is our question here? This is minus 944. See here, this is minus 944, this is minus 834, and this is minus 1687, and this value is P. So what is our P value? So P is nothing but, see here, the model matrix, that is 1 1 1, 0 2 1, and 2 0 2. So now I am going to multiply, so see what happens here. So this will be 4 minus 2 minus 1, this is 2 0 minus 1, minus 4 2 2. So if I multiply this one, then see what happens here. So this is minus 9 plus 0, and this is plus 8. If you see, this is minus 9 plus 8 plus 0, and this is minus 9 plus 4, and this is plus 8. And this one is minus 8 plus 0, and this is plus 8. If you see, so this is minus 8 plus 6 plus 0. So this is minus 8 plus 3 plus 8. So this is minus 16 plus 0 plus 14. So this is minus 16 plus 16 plus 0. So this is minus 16 plus 8 plus 14 plus 14. If you see, D value will be, so D value will be half times of, this is 4 minus 2 minus 1, this is 2 0 minus 1, minus 4 2 2 into, so if you see, so this will be minus 1, so this is minus 1 again, and this is 3, and 8 minus 8, this value is 0, and this is minus 2, and it is, we are very clear that this value is 3, and this is minus 2, and this is 0, and this is going to become 6. So if I multiply, see what happens here, this is half times of, if I multiply this one, so this is minus 4 minus 0, and this is plus 2, and this is minus 4 plus 4 minus 0, and this is 12 minus 6 minus 6, and this is minus 2 plus 0, and this is plus 2, and this is minus 2 minus 0 minus 0, this is a 6 minus 0, and this is minus 6, and this is 4 plus 0 minus 4, and this is 4 minus 4 and plus 0, and this is minus 12 plus 6 plus 12. So if you see properly, plus 4 and minus 4, plus 6 plus 12 minus 12, this is plus 6 minus 6, and if you see, plus 4 minus 4 plus 4 minus 4 plus 2 minus 2, and see what happens here. and D value is half times of minus 4 plus 2 is nothing but minus 2, 0, 0, and this is 0, and this is minus 2, 0, 0, 0, and this is going to become plus 12 minus 12, so this is 6. So if I send 2 inside and divide, then the diagonal elements will be minus 1, 0, 0, and 0, minus 1, 0, and 0, 0, 3. So if you observe this one, this is diagonalized. So, and if you observe this one, so what are our eigenvalues? So the eigenvalues here are minus 1 and 3. So if you observe here, so this is minus 1 and 3 are in the diagonals. So this is how we have to solve, and this is so simple if you follow. And thank you so much for watching, and if you really like this video, please, I'll be uploading many more videos regarding this chapter, and please watch. And if you really like, please take time to raise your thumb and share it with your friends and subscribe to this channel. And thank you so much for staying and spending all your valuable time and attention towards this video. Thank you so much.